Greetings, curious minds. Today, we embark on a fascinating journey into the world of physics, where we will uncover one of the most fundamental principles that govern the behavior of objects and fluids. We are talking about Archimedes' principle, a cornerstone of hydrostatics that has intrigued scientists and engineers for centuries. So, grab your thinking caps and let's dive into the depths of buoyancy, exploring the forces that keep ships afloat and hot air balloons soaring. Archimedes' principle is a pivotal concept in the study of fluids and their interactions with immersed objects. Discovered by the ancient Greek mathematician and inventor Archimedes, this principle elucidates the relationship between buoyancy and the displacement of fluid. According to Archimedes, any object, wholly or partially immersed in a fluid, is buoyed up by a force equal to the weight of the fluid displaced by the object. To understand this principle more deeply, let's break it down. When an object is submerged in a fluid, whether it's a liquid like water or a gas like air, it displaces a certain volume of that fluid. The weight of the displaced fluid is directly proportional to the volume of the object that is submerged and the density of the fluid itself. This displaced fluid exerts an upward force on the object, known as the buoyant force. The buoyant force is crucial in determining whether an object will float, sink, or remain suspended in a fluid. If the buoyant force is greater than the object's weight, the object will rise to the surface and float. If the buoyant force is less than the object's weight, the object will sink. And if the buoyant force is equal to the object's weight, the object will remain suspended at that depth. Archimedes' principle has a myriad of practical applications. It is the reason why ships made of steel can float while a piece of steel itself sinks. By shaping the steel into a hull that displaces a large volume of water, the buoyant force becomes sufficient to keep the ship afloat. Similarly, hot air balloons rise because the hot air inside them is less dense than the surrounding air, causing the balloon to displace a volume of air whose weight is greater than that of the balloon and its contents. The principle also plays a vital role in the design of submarines, the calibration of hydrometers, and even in the analysis of geological formations. It is a testament to the ingenuity of Archimedes that his principle, formulated over 2 millennia ago, remains a keystone in modern science and engineering. To delve further into the implications of Archimedes' principle, let's consider some real-world examples that illustrate its significance. In the field of naval architecture, understanding buoyancy is crucial for designing ships that are both stable and efficient. By calculating the displacement of water, engineers can determine the maximum load a ship can carry without submerging beyond its draft lines. This ensures that the ship remains seaworthy and navigable. In the case of submarines, Archimedes' principle is manipulated to control their depth. By adjusting the amount of water and air in ballast tanks, submarines can achieve neutral buoyancy, allowing them to hover at a specific depth where they can rise or dive as needed. Moreover, the principle is not just limited to transportation. It plays a critical role in the manufacturing industry, where it is used to determine the volume and density of irregularly shaped objects through a process called hydrostatic weighing. This method is invaluable for quality control and material analysis. On a more playful note, Archimedes' principle is at work in the simple joy of floating in a swimming pool. The water displaced by your body provides the buoyant force that keeps you afloat, allowing you to relax and bob on the surface. As we conclude our exploration of Archimedes' principle, we are reminded of the elegance and simplicity with which nature operates. The science of buoyancy, encapsulated in this principle, is a beautiful example of how understanding the physical world can lead to remarkable innovations and technologies. Archimedes' legacy lives on not just in the annals of history, but in every ship that sails the seas, every balloon that graces the sky, and every piece of technology that relies on the principles of buoyancy. His insight into the behavior of fluids has not only advanced our knowledge, but has also shaped the course of human progress. In the grand tapestry of scientific discovery, Archimedes' principle is a thread of pure genius, connecting the ancient world to the modern age. As we continue to explore the mysteries of the universe, let us carry with us the spirit of inquiry and the joy of discovery that Archimedes embodied. As we reflect on the profound impact of Archimedes' principle, we are struck by its universal applicability and the ingenious problem-solving it enables. From the grandest engineering feats to the most mundane daily activities, Buoyancy is a force that shapes our world in countless ways. Archimedes' insight into the nature of fluids and the forces they exert has not only advanced our understanding of physics, but has also empowered us to harness these forces for the betterment of society. Whether we are designing a new ship, exploring the ocean depths, or simply enjoying a day at the beach, we are beneficiaries of the knowledge that Archimedes bequeathed to us. In closing, let us celebrate the enduring legacy of Archimedes' principle, a principle that, much like the buoyant force itself, continues to lift our spirits and propel our quest for knowledge forward. Thank you for joining us on this buoyant adventure through the realms of physics. We hope that Archimedes' principle has inspired you to look at the world around you with fresh eyes, marveling at the forces that keep it afloat. Until next time, keep your curiosity afloat and your minds buoyant with the wonders of science. Thank you for watching. If you're hungry for more knowledge, hit that like button and don't forget to subscribe. Your support is incredibly valuable to us.